Hello everyone, and this is lesson 4 of the Introduction to Houdini series, where we are covering the absolute fundamentals of Houdini. So in the previous video, we saw what are attributes and how to create attributes, and also how to use attributes to modify copies. In this video, we're going to continue with that, but we're going to learn a few more things. Primarily, we're going to take a look at the attribute VOP, and we'll see the difference between how to make stuff in VOPS, and then how to do it in VEX. And also we'll take a look at how to use attributes to modify stuff other than copies. Right, in the previous one we saw how to modify copies, but let's say if you want to use attributes to modify, say, poly extrude or a thickness of a line, or also use attributes to maybe, select a group. So stuff like that, we'll see how to use attributes for, those kind of things. But first we'll start off with the attribute VOP node. So we saw the basic VOP node in terms of, like, there is a node in there called, global VOP, geometry VOP global. And this has the names of, all the attributes or the default attributes that Houdini provides. But now we'll actually use it. So what exactly is the VOP node? So as I mentioned, it's essentially just node-based programming. It's nothing else. And sometimes the attribute VOP node will give you, more ready-made things. So it's easier to just sort of work with that as opposed to, typing stuff in VEX. But yeah, each one sort of, depending on what you're trying to do, you will find some things easier to just, if you can just type a single line of code and that works, it's great. If you want to do something a little more fancy, like maybe you want to apply noise to a geometry, then the attribute VOP gives you ready-made noise node. So that is easier through a VOP node. Okay, so let's just get started, right? So I'm going to take a simple sphere and I will turn it to polygon. And what I'll also do is I'll take a wrangle node and I'll create an attribute. So we'll create an attribute called f at m, okay, and we'll give it a value of 0.2. So we have an attribute called m which has a value of 0.2. Now let's connect this to a VOP node and we will jump in. So the default stuff is fairly simple, right? These are the input values. So if you have any default attribute that is storing a value, that you can bring in from here. So let's also do one more thing, right? Let's apply a color node, which will generate a color attribute. Okay, so if you look at it here, you'll notice that there's only M and P. And then once you apply a color node, you will see that you have an additional attribute called CD. CD is for color. And let's just give it let's make it red. Okay, so this is 1 and we'll make it 0 and 0. Okay, so you just have pure red. And if you want to see this, we can come here and we'll say split pane top bottom and right click and take the geometry spreadsheet. And there you go. So you have M, which is 0.2, and then you have CD, R, G and B, red, green, blue, and CDR is 1, and then everything else is 0. So, just to sort of see this, if we jump in here, okay, so what can you do essentially? Okay, so what you're doing is you have your input, you have the output, and then you do stuff in the middle, right? It's as simple as that. So let's say if I just take the P is position and you get like your 5 default outputs. Okay, you have position, V is velocity, force is force, you have color, and then you have normals. Beyond that, if you want to export or import anything else, like we have M, right? So let's say I want to import M. So then you take in something called bind. So a bind allows you to import and you type in the name of your attribute and you define the type. So this is a float, so we'll keep it at float. If it's a vector, then you can keep it to 3 floats or a vector. And if you want to export, then I can say bind export, and this will allow me to export. Okay, and again, you can give the name of your attribute. Okay, usually you should have the attribute created. So beforehand, you want to be able to create this attribute. But let's keep it to a side for now. So let's say something fairly simple. If I just take a value and I push it into position. Okay, so if you want to take a single value, you can take something called as constant, which just generates a value. And then because position is XYZ, we'll say this is 3 floats. So you'll notice like this is the color of the value and the color of position is the same. If it's on a float, see this is a different color and that's a different color. Okay, so we'll keep it to 3 floats. And then I can just take this and I can connect it there. And what will happen is your geometry disappears. So why did it disappear? Because what it's effectively doing is you are manipulating points, right? Like everything that is happening here is essentially you have data on your points and you're just modifying those points. So when I said 0, 0, 0, and I just push that into position, everything just like all the points are still there. They aren't gone. They just move to 0. So if I click here, you'll notice that, see, there is the point. And if I click on this, you'll see like a whole bunch of points, like they're all overlapping. But see, all your points are still there. The only thing that changed was if you look at the spreadsheet, is like position XYZ, everything became 0. Like if I disconnect this, you'll see, there you go, everything comes back. If I connect it, everything goes to 0. And you can do the same thing with anything. So if I just take this is 0, 0, 0, and I plug it into CD, then it'll turn black because this is black. And if I make it 1 here, then this becomes green. Or if I make it, 1 here, it becomes blue. So you can, essentially just do that. So let's say if I do something else, let's say if I just want to move this. Okay, so I can just take, an add. Okay, and I can add the position with this constant value. And I can put that sum into position. And now what happens is like we have an XYZ. And if I start to modify, so technically now this becomes like, instead of like when we connect it to color, you can think of it as RGB. Now that we've connected into position, you can think of it as XYZ. And then if I start to move this, you'll see that you're basically just, you're starting to add 0.6 to all, or 0.4 to all the values in the Y position. So that's effectively what you're doing. Now, if we want to feed in the M, okay, now what's going to happen is that the M is basically just a float value that we had created, which was 0.2. If I remove the constant and if I plug in the M, then it'll add M to all 3 axes. Okay, so if I just plug this here, you'll see that it moved sort of slightly diagonal. Okay, because what it did was it added, see it like whatever was on 0, it said 0.2, 0.2 and minus 0.8. If I disconnect this, see this is minus 1. So we just added 0.2 to everything, like in one shot. You can also do a multiply, you can do, anything. Everything that you can think of in programming, whatever you're typing in VEX, there will be a node for it over here. We're not going to go into everything. That will be like a 10-hour class, but this is just the basics. Okay, what if you want to just affect, say the y-axis, like what we were doing here, but this is just a float. So what you can do is we can break up the vector into a float value. Okay, and then just affect that one particular thing. So there are a couple of ways to do it, but what I can do is that you get these convert nodes, like which will convert, say, vector to float, or you want to go opposite, so you can do a float to vector. So I can do a float to vector, which is simple enough, and I just want to affect the y. Okay, so I can just connect this M into the second value, and now if I feed this in, see now what you've done is, if I sort of break this out, see now you're only moving it in the y-axis, or if I want to move it in the x-axis, so I can just plug this here, and now I've plugged it into the x-axis. And if I come up here to my attribute triangle, and let's say if I make it 0.5, you'll see it moves. Okay, or then if I just make it, say, at time, then you're essentially just going to get an animation. And the thing is, you're not moving the object. You're essentially just moving points, right? That's basically what you're doing. Now, if you want to do something else, so this is, this is really, really basic stuff. Okay, but I'm just trying to sort of, explain the concept of it. So one more thing you can do is, let's say if I want to generate a parameter, right? Like, because if you come up, there's nothing. Like every time you want to make a change, you have to go inside it. But let's say I want to create a parameter called move y, and which will allow me to move this object in y-axis, right? Like roughly that. So what you can do is you can actually take something called as a parameter. And we can say this is, again, so you want to give it a float. The name is very important, and as many parameters as you have, they should each one of them has to have a unique name. If you don't have a unique name, then the first one will override the second one, right? Like this is called PARM. And if I do a Control C, Control V, you'll notice that the second one, everything is locked out. Why? Because this is the same name as that. Okay, so that is, you have to remember that. So we'll just call this as move y. Okay, and you can create a label for it. So I'll say a label is move y, and I can just plug this into the second input. And what will happen is, the minute I've created this, if I come up, and you'll see that you've created a parameter called move y, and I can actually move this now. And so here again, if I type in at time, so you effectively created, okay, hold on. I think the other one is also time. So let's make that into nothing. Let's make that 0 or 0.2 as we had decided. Okay. And so what's going to happen is you're just going to move positive in y-axis. And because it's just like you're just working on points and not anything specific, if I replace this with anything else, like let's say if I take test rubber toy and plug this in, you're going to effectively get the same result. It's looking darker because I generated a color on it, but there you go. See, this moves up. So anything you're doing, you can just, you can plug it in, you'll get the same result. All right, now let's do something a little more complex. So what we'll do is we will create our own mountain node, right? So the mountain node that you have, which is like a displacement. So we'll create our own mountain node, and then we'll, do something more complex with it, which is not available in the mountain node. So you get an idea of, what you can do with an attribute VOP. All right, so let's keep this to a side, and I'll create another VOP node, and we'll call it displace. Okay, wrong spelling. Yeah. And let's just increase the number of segments. So, or the frequency. So we'll make it about 20. So we have, enough. And yeah, I don't want any of this. So let's just keep this to a side. It doesn't matter. All right. So let's take this. And then what I can do is, I basically want to create a displacement modifier. Roughly, that's what I want to do. So what you do is you get something called as displace along normal, which is a ready-made thing. So stuff like this is something that you probably wouldn't do in VEX, because trying to build something like this would require a fair bit of code. And this is, ready-made in VOPS, so you don't need to worry about it. The second thing I want to do is I want to take a noise map. So you get multiple types of noise maps. The thing to remember is that the VEX builder, which is sort of written here, this is the same stuff you will get when you do complex shader building in Houdini as well. So a lot of the shader nodes are actually all the shader nodes are available here. Okay, and you can also, even if you're building this here, you can actually copy paste the same nodes into your material, and they'll actually work over there. Okay, so it's pretty flexible, but that's a lesson for a different time. Okay, so what you can do is you can just take something called turbulent noise, or if you press tab and you come to noise, you'll see like there are a variety of them. So the biggest one is called unified noise, but yeah, you get a whole bunch of them. I'll just take turbulent noise because that's like small and simple. And then if I the way it works is you take the noise, plug it into amount, and then you take the position and plug it into position, and nothing happens. The reason why nothing happens is that the noise needs to be given a position, right? Like how is the noise working? You either need UV mapping, or you need like, 3D position space, like object space for the noise to work. So you just take the position, like the P from here, and plug it into position, and that's it. See, there you go. So you have a noise map. And another thing you can do is you can create parameters for the noise map, because right now if you go up, you'll notice that this has no parameters. So we saw how to make one parameter early on, but what if you want to create parameters for an entire node? So you have two options. One is you can click on this little gear on the side, okay, which will, like, you can click on it, you can say promote parameter, and this will create one parameter, like it'll promote this particular parameter up top, right? So you'll get this little input over here, but what it is it's essentially just a collapsed node. So if you double click on it, you'll see that it's created a parameter, and its name is type and the label is noise type. So if you come up, you'll see that you have this one guy, and you can change the type of noise. And if you want to create it for the whole thing, so I can just get rid of this. And what you can do is you can just right click here and come to VEX options, and you'll find something called create input parameters. And if you click on that, it'll just create parameters for everything. So if you come down here, see, you'll get all of this. And the reason you want to do this is because if you want to animate a noise, or if you want to animate any parameter, you can't do it at VEX level. Okay, inside the VEX builder, you can't do animation. So if you want to animate, you want to promote it, then you can animate it. And also it allows you to do, your basic channel referencing and all of that stuff. So this is another thing to remember. So whenever you take a noise map and you want to promote, not the whole thing, but even if you want to promote just specific parameters, this is how you can do it. But right now I don't want this, so I'll just delete this, and I'll make another turbulent noise. And let's take the same thing again. So position and noise goes in here. Okay. And pretty simple, straightforward, nothing fancy. What you can do here, which is where it becomes interesting, is you can actually take multiple of them and mix them, right? So if I take this, and I can do Control C, Control V, and then I can just take an add or a multiply or whatever. So let's do one thing. Let's take a subtract. I don't know what a subtract will do, but let's take a subtract, and then I'll convert, like, let's just take a look at, let's make something else with this. So you have multiple types of noise here. So I'll just take original purlin, and I'll adjust the offset a bit. I'll lower the amplitude, and like increase the roughness, and maybe adjust the frequency. Okay, so let's take this, and now we'll subtract these together. So I'll take this and I'll put this in, and yeah, it's not really doing anything. Let's take an add. Okay, so we'll take an add here. Let's see how this works. So we'll take an add, and I can just plug that in. See, so you're essentially like adding them together. So what you can't do with the mountain node is essentially stuff like this, where if you want to take like multiple noise maps and just sort of mix them together, you can very easily mix them together. Where it gets even better is that you can actually, you can think of this as shader building essentially. So let's say if I have two different types, so let's say I have this one, and I'll take a unified noise. I'll take a unified noise static. The unified noise is actually a pretty big node. The position node, in the position input in that comes a little low. So you can just take the position here, and I can plug this in. Yeah, and let's plug that here. Okay. And what I want is I want to take like a whirly, which will give me like cellular noise like that. Maybe increase the frequency a bit. Okay. And let's say what I want is I want to mix this together using like a gradient. Okay, so I want to do like a y-axis gradient and then mix it, with that. So here is where things become a little more interesting, which is you can create parameters. Like we saw how to create a parameter, but you can also create ramps. Okay, so essentially like when we take the color node and you have this option here called ramp, so you generated a ramp. So we can do the same thing within a VOP. okay, which is essentially where it comes from. So you can minimize these nodes by clicking on this. So if you click on that, it will minimize. If you click on this one, it will minimize. So let's say what I want to do is I want to take the bounding box of this object and then take the Y part of it and generate a gradient. And so that will give me like a black to white gradient. And then I want to use that to mix these two noises together. Let's say that's what I want to do. So that sounds like a complicated thing, but it's actually pretty simple. So what you need is you need the first input, which is like, this object itself. And you look for something called as relative to bounding box. I'm doing the setup in here just to give you an idea of what you can do with this. But there is another way to do this as well. And I'll show that once this is done. Anyway, so what it needs is it needs the input. So you just take the input 1 and plug it in. And then this is a vector. Okay, this contains like X, Y, and Z. We just want the Y. So we want to extract the Y. So you take a vector to float and just plug it in. So this will give me X, Y, Z. And just to see what you have created, if I just take the Y value and I plug it into color, see, basically that's what it is. Like if you just take all of this and plug it in, you'll essentially just get, it's RGB. So, red is X and G is Y and B is Z. Okay. Now you can also see it here, right? Like if I plug this in over there and if you come into the color, and it actually has an option for bounding box. Like you can just say bounding box, see, you're effectively getting the exact same thing. Now, we just want the Y-axis. But what I want to do is I want to control the Y using a gradient. So I can control it better. Like this is a single gradient 0 to 1. I can't control this. So let's say I want the black till here and then up, beyond that it should be white. So how do you do that? So just type in ramp and you'll get something called ramp parameter. And by default it goes to color, but I can also have a spline, which is okay for this. And let's just call it Y. So it needs an input. So we say this is the input and we plug that out. And what this will do, you'll get the same result, but you'll notice now that we have this spline. So now let's just mix, all of this together. So as I said, like what you're doing, leaving out this bounding box bit, is you're essentially just doing material building. So if you've done node-based material building, this is not going to be, anything different. So you'll get something called as a mix, which will allow me to mix these things together. And what I want is input 1, input 2. So input 1 will be the black area, input 2 will be the white area, and the bias is the mix amount. So let's say turbulent noise is below, and then the cellular noise is on top. We can put the blend in there. And so what you'll get is, see, you can actually mix these two together. So you're mixing between this and that. And then all I do is I just take this Y amount and I plug this in. See, and there you go. So if I come up here and let's remove the color, this was just for show. So we'll remove this. Yeah. So what you're doing now is if I take this and I plug it this way and I plug it that way. See, so this part is, let me just, let's get this to 100. Yeah, see, there you go. So this is all the noise and then this is all the cellular. And then if I want to reverse it, I can reverse it. So I can just take this to 0. So this is on top and then I can take that to 1. See. Okay, so this is building it, internally. But what if I want to, use something else? So that is where the bind node comes into play. So the great thing about the bind node is, if you're bringing in a value, you can use that value as a mix amount as well. So what I can do is, let's say if I come in here and I'll take a mask. So let's say I'll do a mask from geometry. I'll take another sphere. Okay, so this is 1 and that is 2. Okay, and let me just take a transform. Yeah, and just move it to a side. And see, there you go. Okay, so we've created a value called mask, which should be there. And now what I can do is I'll just plug this in and I can bypass this guy. Okay, like I don't need this for now, but we'll bypass this. So you can just, so it'll just go back to a standard mix. And what I can do is I can just take a bind. So I can take a bind and we'll bring in mask. And I'll use the mask for doing the bias or the mix amount. And there you go. And so what you've done very, in a fairly simple way is that we've created an effect which does this. See. So you can animate this and get like different results out of it. And you can also, like, if I come into my mask and then I can adjust the radius if I want to. And I can also, like do something fancy here. So I could probably do, something like that just to create a little more interesting. Yeah, so if I just plug this in, see. Alright, so this is what you can do, with an attribute VOP node. So I didn't want to do anything too complicated, and using noise maps and doing displacement is a fairly sort of standard usage of VOPs, okay, or something that I do quite often. And it's very easy to sort of define as to, a place where you would traditionally use an attribute VOP over just trying to write code, because writing this as a code is going to be a fair bit of work. Alright, so we saw how to mix multiple noise maps using a custom attribute and how to do that in an attribute VOP. Now let's continue, and what we'll do is we'll see how to use attributes to affect something specific like a poly extrude. Okay, so let's say if you generated a noise map and you want the extrude to happen based on that noise map. So how would you do that? So let's just take a grid, and I'll keep this fairly simple. So I'll just take a grid and let's minimize this. I'll press Shift W to bring up the wireframe, and let's just give it a few segments. Alright, so now, like, you can generate a noise map using the attribute VOP, but since we have a noise map node, we can just take attribute noise, right? And we can just build it based on that. So this generates a color noise, which is fine. And what I can do is, let me just adjust the element size so it's fairly big. And maybe lower the roughness as well. Right, so this is fine. Okay, now what I want to do is I want to use, like, this is RGB, right? So if I come in here, you'll see like it's affecting, it's not one channel, right? Like you can try to make it one channel. Like I can say 1D and that will generate just a 1D noise, which is fine as well. But let's keep it to RGB so that we can use the different color channels to affect different things. So the first thing I want to do is I want to adjust two things. I want to adjust the height of the extrude and maybe the inset of the extrude. And I want to do that using custom attributes. So what I'll do is I'll take a wrangle and I'll create two float attributes. So I'll create, say, f at d, which is, say, for distance. So let's call it dist. And this will be at cd.r. So this is the red color. And then I'll create another one called f at inset. We'll call it in. And this is at cd.g. So the inset is happening based on the green value and the extrude is happening based on the red value. And let's also do one thing. Let's take the noise and we will animate this. So the simplest way to animate is you can take the offset value and just animate it. So I'll come into the y offset and put in at time. So you should have an animated noise map. Okay, pretty simple. Now let's take a poly extrude. Okay, and what we can do in the poly extrude is if we give it a distance value, you'll see it extrudes. And I'll say individual elements and also give it a bit of an inset. Now the way it works is you come to local control and it has this option for distance scale and inset scale. So what I can do is I can turn on distance scale and just type in the name of my attribute, which is dist. So I can just come in here and I can type dist, but nothing happens. Now, why is nothing happening? So the reason why nothing is happening is because you are extruding faces or extruding primitives, and my attribute is at point level. So these attributes need to be at primitive level for them to affect an operation that's affecting primitives, right? Simple. So the simplest way to do it is there is something called as an attribute promote. So an attribute promote allows you to take an attribute from one level and go to another level, right? So if it is on points and you want to transfer it to primitives, you can do that, or vice versa, or anything actually. So I can just come in here. Let's do this before the wrangle. So I'll just come in here and I want to take the color, and original class is point, new class is primitive, and that's effectively it. Like if I check this, see now your color is at primitive level. And then we come to the wrangle node and you can see nothing is happening because the wrangle node is affecting points. So we change that to primitive as well. And now if you come to poly extrude, you'll see the change. If I press play, see your extrude is now, based on that. And the same thing I can do with the inset. So if I just come in here, it's called in. So I can switch on the inset scale and just type in. See, so what's happening now is the green values are affecting the inset and the red values are affecting the extrude. All right, so this is working. Now let's do one thing. I want a little more control on, how the gradient is forming or how the noise map is forming. So let's say if you want to create a ramp here, right? So we created a ramp inside a VOP node. So how do you create a ramp or a simple parameter in the wrangle node? So to create a simple parameter, the option is fairly simple or fairly easy. Is let's say I want to multiply this by a value. Okay, so the simple thing is you just type in ch, which is a channel, a parameter is a channel, and then just double inverted commas and give it a name. So let's just call it height. Okay, and then close it again. And then what you can do is just click here, which says on the absolute right, you'll find something called create spare parameters, and it'll create that parameter called height. So if I multiply this, see, so now I can actually, take this higher. So this is for creating a simple parameter. How do you create a ramp? So a ramp is relatively, slightly more involved. So the function is called chramp. Okay, so chramp. And then the first thing required is the name of the ramp. So let's just say R is the name of the ramp. And then what is the attribute that it is using? So it's using cd.r, and close it. Now, if there's an error, it will tell you that there is an error, but everything is fine. So just click here. And what this will do is, see, it's created a ramp for you. Okay. And now you can do a little more work with this, which is I can just come in here and let's say you have different types of interpolation values. Usually B-spline is what I prefer. So let's take a B-spline and then I can just control it. See, so I can, essentially do something like this. See, so you have like a little more control, and maybe we can push it up a little more. So what you're getting now is, see, it's much more, interesting. And I can do the same thing here. So let's say if I do chramp and let's call this as G, and click here. So you'll get another ramp. This is for G. And again, we'll keep it, or let's keep this to linear. So I'll say some of these are, absolutely flat, and then some of these are very pointed like that. Or maybe you can also create, a few of these. Yeah, see. So what you're getting now is you're getting a little more control on how the noise is affecting the extrudes. Okay, so since we are doing, ramps and attributes, let's take a look at another, relatively simple example, is how we can use ramps and attributes to affect, say, something like a thickness of a line. So we've been doing that rock and flowers project. So let's say if you want like a tapering line, how would you do that? So this is a relatively, it requires a few steps primarily. Okay, so I can take a line tool, and then let's do one thing. We'll give it a bend like we had done before. So I'll just take a bend. And again, like last time, I'll get the capture direction to Y and just bend it a little bit. Okay. And then there are two ways to do this. I'll tell you the simpler way. Okay, so we did the PT num divided by num PT, fairly early on. That is one way to do it, which is generate a ramp going from 0 to 1 based on the curve direction. But there is another way to generate an automatic attribute which will do the same thing for you. So the way to do that is you get something called as a resample node. Okay, so take a resample node. A resample node just allows you to resample a curve. Like you can take it and you can increase the number of points on it. Okay, based on length. So if this is 0.01, which means as the length will keep increasing, the points will keep increasing. So technically, like you're getting 1 point every, 0.1 distance. So a length of 1 will give you probably like 10 points. So if I switch this on, see, you have 10 points. So if I have a length of 2, it will give you 20 points. Okay, so because it's every 0.1, you're getting a point. But if you want a fixed number of points, then you can keep it to maximum segments. So now, no matter what you do, like it's 14. So as much as I increase this, it will always remain 14. But those things kept aside, you can also keep it to like subdivision, which is useful because like right now you're getting segmentation, right? And if I try to increase this, you'll see it still remains kind of segmented. Like this is the original line and you're getting these segments, and the line maintains those segments. Like if I see, you can get these segments. So what you can do is you can come down here and you can say treat polygon as subdivision curves or interpolating curves. Interpolating curves gives you, like you can see the hull over there, and subdivision curves sort of like, flows inwards. So we can keep it to subdivision curves, which is fine. So then it sort of like, smoothens out the curve for you. But like, let's go back to a distance of 1. Anyways, the nice thing with this, and the reason I'm showing this is because this is a pretty nice, simple trick, is you can come down to the resample and there is an attribute called curve view, which essentially generates a 0 to 1 value going along the curve. And you can see this, like if I open this up, if I go to curve view, see it starts with 0 and then it ends at 1. Okay, and so you get like a nice little gradient here. If you want to visualize this, there's a very simple way, like we can press X and then I can come down here to the visualize and we'll say curve view, and you'll see a gradient, like a red gradient forming. Okay, so 0 to 1. And then what I can do is I can actually take a wrangle, and you can use a p scale also, like that's fine. So I can say at p scale is equal to, we'll do a ramp. So we'll do ch ramp and we'll call this as T for thickness, comma, and at curve view, which is the attribute that we generated, and close this. And then you can do like now anything that happens on this curve is going to do that 0 to 1 thing. Click the plus here so you'll get a gradient. And then if I take a polywire and I plug it in, like right now nothing will happen, but if I come into the radius and I type at p scale, see, you're getting this. And then I can come in here and maybe, just make it thicker or thinner, see. Or what you can do is you can, multiply this further by an additional value. So I can say multiply, with say m, which is like multiply. So what will happen is that you can have an additional value for overall thickness, and then this gives you the basic shape. So you can, define things that way. So if you want to create a grass strand or anything fancy, you can do stuff like that. But also, like if I decide to copy something on this, so if I take a box and if I just do a copy, we'll do copy to points and we'll do an orientation. So we'll do orientation along curve and just plug this in. See, so now your copies look like that. See, so whatever you're doing here, you're getting like, and the nice thing is that if you come back to the resample and increase number of points, the gradient is maintained. Okay, because it's just generating that value going from 0 to 1 based on, the curve you attribute. So you don't need to worry about that. So yeah, so this is how you can create ramps inside of a wrangle node and then use those to affect, multiple things. So whether it's how to affect extrudes or how to affect thickness of curves or things like that, this is where, the warp node or the wrangle node becomes really, really useful. All right, now let's take a look at two additional functions which are usually quite useful and they get used a lot. The first one is the random function and the second one is called a fit range. Okay, so again, let's just take a grid and let's say I want to do like random extrudes. So one of the simplest ways to do it, like again, we're just going to do a little bit of stuff through wrangle, is I can work this on primitives directly and we'll make an attribute called distance. So f at distance. And let's say I want to use the primitive number. Okay, so let's just put in a value. If you go into the VOP, if you go into an attribute VOP, you'll see you have something called primitive number. So what I can do is if I just come in here and I type at primnum, which is the primitive number, and then if I do a poly extrude, so I'll take a poly extrude and the same thing. So I'll just take individual elements, extrude this a bit, slide and set. So you get a little bit of distance between them. Local control and type in distance. And see, what you've gotten is each face is extruding to the amount of its primitive number. So if you come down here, see, so 80 is going all the way to 80 and then 0 is sticking to 0. But what it does is that it actually multiplies it with the distance value. So if the distance value is 1, then it's going all the way to 80. Okay, but if the distance value says 0.1, then it's not, then it's only going to like 8. And now what I want to do is I just want to randomize this. So what I can do is I can just come in here and the function is called RAND. Okay, it's pretty simple. And just just put this into randomize. That's it. You press enter, then there you go, it randomizes it. And then whatever value is here, you can see that it's random. Okay, so it's fairly simple, like it's not something overly complex. It's a nice way if you just want to randomize scaling of objects or, random extrusion, anything else that you want to randomize. All right, so now let's use the fit function. Okay, so the fit function essentially takes any incoming value and then you can reset it to another range. So just to give you a very simple example, if I take this, this random function that we have, and we will put this into a fit function. So just take fit 0, 1. So what that means is that it is expecting that the default incoming range is 0 to 1, which is what the random value will generate. If you want to see that value, you can just come in here. And again, we can just press X. And let's say I want to visualize the distance function. So if I come in here and type in dist, see, there you go. So it's coming in red, but let's change that to a marker and there you go. See, so these are all the values that you're getting. or you can see them in here, which is also fine. So this is only showing points. If you want to see primitives, you click here. Okay, so that will show you primitives. And there you go. So now you can see like nothing goes over 1. It's all between 0 and 1. So that is where the fit 0, 1 comes into play. And then I can just take fit 0, 1. And what is the function that you are modifying, or what is the attribute that you're modifying? So we're modifying this random at primitive number. And let's say I want to go between 1 and 5. Okay, so pretty high. And so if I come into polyextrude, you'll notice, see, now it's gone between 1 and 5. Or if I wanted to go between 0 and 5, I can do 0 and 5. Okay, or maybe 0 and 8 or 9. See, so you can very easily do, stuff like this. So this is where, you can use the random function and the fit function to generate, or to control attributes in a better way. Okay, so along with your basic ramps, if you just want to push values to a different range or just randomize them, that is where, the fit and the random function comes into play. Now, another thing you can do with random and fit is we can also use them to select points randomly, okay, or select faces randomly. So how do we do that? Okay, so let's just take a look at, something relatively simple. So I'll take a grid, and let's say I want to scatter some points on it. So I can just take a scatter. And let's say I want to randomly select half these points. So, and then let's say I have a sphere and a box. And I want to copy like, half these things on a sphere, and half the point should have a sphere and half the point should have a box. Okay, or let's do a torus as well. Or not a torus, let's take a tube. Okay, so we have these 3 things, and let's just say for now I want to worry about 2 of them, and then we'll do something else. Okay, so I'll just take this, and what you can do is just come to a group, and we'll do group expression. And I want to select the points. So change this to points, and we'll call it A. And what you can do is you just randomize the primitive numbers, and then you define a range for it. So, or you define like how much you want to select. So just take random at ptnum less than, let's say I want to select only 40% of these, so less than 0.4. And see, that's basically what you've done. You've selected these many, and then I want to select a reverse of it. So let's take a group combine, and I can say B is not equal to A, and that's it. So I can take a copy to points, and we'll take both of these, and let's say this is the sphere. Okay, and this goes to A. So the target points is A. Let's make it really tiny so we can see them. Okay, same thing here. And then I'll pick another copy to points, and this will be separate. And this, in the second input, and this will be B, and that takes the box. And then if we merge them together, you get that. Okay, so we have boxes. Let's just give them some color as well. So I can take maybe, pink and say green. So if I come up to the group expression and I say 0.1, say, so you have the spheres are only 0.1, like, or 10%, and the rest of them are boxes. And what if you want to change the selection? You just take the ptnum and you add it with a value. So that becomes like, if you're doing a math expression and you have an x in there, so every time you change the value of x, you get a different result. So when you add something to ptnum, that becomes like an x. So whatever change I make over there, if I keep changing it, see, you'll keep getting a different result. So this is one way of doing this. So this is how you can use like the random function to select, or to make groups as well. Now let's do something a little different, which is, let's say I want to use I want to generate like a noise map, and then based on, let's say, grayscale values, I want to generate 3 areas, and those 3 areas should get, 3 different objects. Okay, so let's also take in this guy. I'll just plug this in. We'll do Control C, Control V. Yeah, let's give this a cap, make it polygon, and okay, and just give it a different color. So we'll make it, say, blue. Okay, so how do we do that? Okay, so let's do one thing. Let's just duplicate this. So we'll do Control C, Control V. And what I want to do is I just want to generate a noise. So we'll take an attribute noise. And now if you keep it to 3D, it generates a color value, which is a CD. If you keep it to 1D, it will just generate an attribute called CD. It's not going to be RGB, because if you open it up, you'll see like it's just called CD. Like rather than when you keep it here, it says like, this is gone into a vector, but default, if you just keep it to, this, it'll just go to, CD, which is fine. So we just want a grayscale value, which is being generated. Okay. And then what I want to do is I want to take a wrangle node, and the first thing I want to generate a ramp which will break this up into 3 sections, or three areas. So I want to create an attribute called R. Okay, and this will be ch ramp, and just call it anything. This is the name of the ramp, so it doesn't really matter. And then we'll take @cd. Okay, so there you go. So once you click there, you'll generate a ramp. And what I want to do is, let's just visualize this, right? So I'll press X, and I'll come in here, and I want to visualize R. So which should default give me, like if I set it to marker. Okay, let's do one thing. Let's just come in here to this attribute, and let's just call it something else. So let's call it C. Okay, like just something. So let's just say this is @C. So if I come into visualize, I should see, there you go. So now we have, our gradient, or at least we are seeing, the changes happening. See, so this is like, you're basically getting like a red gradient, which is fine. So come down here, and then what I want is, I want some of them to be like completely black. So at 0, and then some will be at 0.5. So 0.5, and then some will be at 1. So like that. Okay. And then we can just really push them in like this. So it's very, very, so technically we have 3 ranges. If I come into visualize, change this to marker, we should be able to see, there you go. So mostly it's 1, and then it's 0.5, and then some of these should be 0. They'll be there somewhere. Yeah, let's try something. Let's come into the attribute noise, and we'll remap it to, let's try 0 and 1. Yeah, there you go. See, so now it's a little bit better. Okay, so we can do a remap. Yeah, you're getting some of them which are, like a different value, because the range is like this, like you have a little bit of a slope in the middle. But if you don't want that, we can set it to constant, right? So what I can do is I can just remove all of these, and I can set these points to constant. And so I can have one value here. So this is from here to here, it's all 0. Let's say this is 0.5. And then I want a third one which goes to 1. So this will also be constant, and there you go. So this is 1. So now you're getting like, absolute fixed ranges in there. So this is 0.5, and then this is 1. Okay, so this is good. This is fine. Now what I want to do is I want to reset this range to say 0, 1 and 2. Because what we're going to do, now I haven't really explained where we're going with this, but within copy to points, there is a newer function which allows you to distribute multiple objects based on, an integer attribute. So if let's say you have an object which has an integer value of say 0, and you have another one which is 1 and another one which is 2, and then on the points you have a similar spread of say 0, 1 and 2. So wherever it is 0, you'll get the object 0, and wherever it is 1, you'll get object 1, and wherever it is 2, you'll get object 2. So what I can do is I can create an integer attribute. So we'll call it I, and I add, let's call it variant, because that's what it looks for, but you can have any name that you want. And I want to do a variant of R. So I'll do fit01, and I want to take R. So we'll do @R, and it goes between 0 to 2, because we have 3 objects, right? So 0, 1 and 2. And so close this, and if I visualize this guy, if I visualize variant, if you have done everything right, we should get this. See, so we have 0, 1 and 2. Okay, like you can see them here itself. Okay, so we've successfully done what we wanted to do. Now let's use this. So what we do is we take our 3 objects. So I'll just disconnect these guys, and you need to create the same attribute here. Okay, so keep them to a side and just create a wrangle, and we create I at variant is equal to 0. So let's say this is 0. So it's 0, 1 and 2, or any order that you want. Okay, so plug this in and then Control C, Control V and plug that in. So this will be 2 and this will be 1. Okay. And then if you come to copy to points, hopefully this should work if I've done everything right. So what you want to do is you just want to merge all of these together. And then this comes in here, this goes in there. And all you have to do is you switch on piece attribute, and there you go. So once it finds a variant in there, it automatically distributes it based on those values. So what we did was we generated a noise map called C, and then we used a ramp to adjust C into 3 equal sections, or 3 sections essentially. And then we used a variant with a fit range to reset it between whatever you want. Okay, so if I bring this down here, see, so as you adjust this, you can sort of adjust that accordingly. And then if I adjust the noise map, if I animate this, let's say if I do like at time, then you can very easily just have these guys adjust. Okay, so along with this, let's say if I want to do something fancy, like I want the distribution to look a little smoother, is I can set this, I can use the C to also do scaling, right? So I can just come in here and I can do add P scale, is the same thing. Like I'll just do a Control C, but you'll have to give a different name because ramp M is already being used. So we'll call it, say N. Okay, and just plug this in and see. So what you get is that, and I can just do a little bit of scaling here. And now if you press play, you'll get like see, it's a slightly smoother, distribution between these guys. Or maybe I want the boxes to be smaller, I want the spheres to be bigger, like that. So you should get, so the boxes become small, and the spheres remain big. Alright, so this is how you can use the fit range to also do, groups and distribution of copies. So this is a new thing. This variant stuff is new to Houdini 18. So which is why I wanted to cover it, because the earlier method of random distribution of objects was a little different. This makes it, much more easier overall. Yeah, so that's effectively it. So this is how to use VOPS and the Wrangle node to generate parameters and gradients and ramps to further control attributes, and then how to use them to affect like a whole variety of things. Alright, so the next video is going to be completely different. So the next video, we're going to deal with LOPS, which is the new sort of lighting context in Houdini. So we'll take a look at LOPS and we'll see how the new area sort of helps you, light and do look dev of your scene a lot better in a much more sort of, refined and organized fashion. So that's what we'll take a look at in the final chapter.